All right, class. Today I'm going to be doing a review for the first exam. So hopefully after this, you'll be able to know kind of what to expect on the first exam and what you'll be allowed to use on the first exam and all that kind of stuff. So let's go ahead and get started with it. Okay. All right. Okay, so the exam is going to be Monday and Tuesday, July 6th and 7th. So you'll be able to take it all day, either Monday or Tuesday, and it closes Tuesday night. So make sure you get on Learning Suite and take it then. The test will be given on Learning Suite, just like you take your lecture quizzes. So under the exam tab is where you'll find it. And yeah, so same process as taking those lecture quizzes. Okay, so this is kind of adapted from what I usually have for the exam one. Okay, so, but there are 24 multiple choice questions usually, right, for the first part. And half of those require calculations or about half of them require calculations, and half of them are kind of a concept or trend. So like which of these elements is largest or something like that. And then there's usually a short answer as the part two, where you'd write on the test and fill it out and stuff. But I've converted those to be able to do online, and there's like 58 of them now. So when you log in, it says there's 82 questions total, which looks like a lot. But there's really 58 of those questions come from 6 short answer questions. It's kind of crazy, but just the way I had to do it required me for like one question. Sometimes there's like four like fill in the blank boxes or something just to answer what would have been like one part of a short answer question. So don't be intimidated when you see 82 questions on there. It's really about 30 questions. I mean, 6 of them are short answer and have like multiple parts to them. So for example, like one short answer question would say like, give a list of like 6 different elements and say, what is the symbol for each of these, right? So that's one short answer question turned into 6 short answer questions online, but you can run through those pretty quick. So don't be alarmed when you see the number of questions at 82. A lot of them are pretty quick. So anyway, so for the short answer portion, which is really kind of just fill in the blank questions now, you'll need to know element symbols and names. So going from an element symbol to a name, or a name to an element. And you'll just need to know or memorize the first 20 elements for those questions. Another part of it is ionic compound names and formulas. So given a formula, be able to produce the name, and given a name, be able to produce the formula. And then also know the names for the polyatomic ions. And if you're given a polyatomic ion, know the name. If you're given the name of polyatomic ion, know the formula of the polyatomic ion. So going between names and formulas for ionic compounds, polyatomic ions, and then also for covalent compounds, you'll need to go between names and formulas as well. And then the final concept will be Lewis structures. So obviously you won't be able to draw the Lewis structure in like Learning Suite. So the questions basically require you to draw it out on your own and then answer a few questions about that Lewis structure. That way I can kind of still test you on drawing Lewis structures. So I think that's the best way I'm going to be able to do it for now. So, but those are the concepts that will be on the short answer portion. Okay, and then honor code obviously is very important. We're not doing this in the testing center, so I'm completely just trusting everybody to be honest. So I've listed here what you can have, okay? And if it's not on this list, then you can't have it, okay? So you can have a blank scratch paper, multiple sheets of blank scratch paper if you want, a pen or a pencil, a calculator, and then you can have the equation sheets, and then there's a list of elements and their names. I'll show those to you. So there's 3 sheets you can print out to have with you while you're taking the exam. And then just have the exam open, and that's it, right? So just open one tab on your browser. It should be the only thing up on your computer, and take the exam that way. Close. You can't use notes. You can't use the book. You can't use a neighbor. You can't use a friend. Nothing like that, right? So really, you're pretending you're in the testing center, with just scratch paper, a pen, calculator, and then the equation sheets that you'd have. Okay. All right, so we're going to go over some of the topics that you need to know. And this is stuff that we've already covered in the lectures, but I'm just doing a general overview here of what you need to know. Actually, sorry, before I go through this, let me show you on Learning Suite where to find the information for the exam. Okay, so if you're on Learning Suite and you go to Content and then click Exam Info, so these are the 3 sheets that you can have on the exam. So the first one is an equation sheet that has a few different equations. It has some constants, right? So like this is like the heat of sublimation, heat of fusion, heat of vaporization for water. Okay. There's a lot of different conversions on here. Electronegativities we haven't talked about yet. And then there's some different formulas over here, like the Q equals M cat, Q equals M delta H, right? None of these I really care that you have memorized, so they're going to be given to you on the exam, and you're just asked to use them, much like you would with like a homework problem. The second sheet that you'll be able to have on the exam is this periodic table, okay? So it gives you the element symbols with the masses and the atomic numbers. And then the last thing you'll have is just this list, because I only asked you to memorize elements 1 through 20. So elements 21 through 118, I have the name and the symbol here. So you can use this as a resource if you want, but elements 1 through 20, you need to just have memorized before the test. And when you're using these sheets on the test, obviously you can't write on them or anything like that, right? It's just what comes printed off is what you should be using. Okay. All right, we're back. Okay, sorry about that. And then also under this tab, you'll find just some information that's probably interesting. So if you go down to like the midterm 1, that's the exam 1 that we're going to be taking July 6th and 7th. The historical average has been about 72%, the median about 76%, and generally takes about an hour and a half to complete. I'm not sure how much that's going to change, like being fully online, but I imagine it would be pretty similar to that. So I would, you know, if you're you probably know by now if you're a slower test taker or a faster test taker. If you're a slower test taker, make sure you have at least a good like 3 or 4 hours to take it. You know, just make sure you got enough time. You don't want to be closing the browser and coming back. I want you to take the test in one sitting. So yeah, anyway. All right, sounds good. I think that's about it for that. Oh yeah, and then the exam will obviously be here under the exam tab. So you have all these different lecture quizzes. You're used to taking these, right? Exam 1 is just on this list as well, July 6th and 7th there. Okay. All right, let's go back to the PowerPoint. Okay, so let's talk about what you'll need to know as a general overview. So you probably have realized by now you need some basic math and algebra skills to solve these problems. No scientific notation, right? So when you have, if you're converting between like 120, you want to convert it to scientific notation, right? Be able to convert any number really to scientific notation. Okay, and then go from scientific notation back to the number as well. And a lot of this is, on mastering chemistry. The test is basically mastering chemistry type stuff, or like end of the book type questions, but no notes, right? So if you can do the homework and stuff without notes and you can get through it pretty good, it's a pretty good gauge of how well you'll do on the exam. If you find yourself looking at your notes or the book or on Google or something a lot while you do the homework, then you need to work on those ideas before the exam, because you obviously don't have those resources on the exam. So that's kind of a good gauge for how the exam will go. Okay, and then using prefixes and units to create conversion factors. So as far as the conversion factors and equalities that you need to know, I've gotten a lot of questions about that. All I really care is that you can go from like in this zone off the top of your head, right? So if you need to go from like grams to kilograms, you should be able to do that off the top of your head, or grams to milligrams. You should be able to do these, right? But I wouldn't ask you to go from like grams to nanograms or something without giving you the conversion. Okay, so just know within between like kilograms and milligrams in that region, right? You should be able to go in that area off the top of your head. Everything else will be given to you either on the equation sheet or just in the problem. Okay, so you don't need to memorize a bunch of conversion factors and stuff like that. Okay, so then just remember, when you have an equality like this, you can rewrite it, right? So this could be rewritten as this right here, right? So you can write it as an equality with either one on top or either one on bottom, as you can see here. All right, sounds good. Okay, and then also just be able to use the conversion factors to solve problems like you've done on mastering chemistry. Okay, so you might have just simple one-step conversions, right, where you're converting miles to feet or something like that. You might have multi-step conversions, right, where you have to go through multiple conversion factors, which you've seen these on your homework as well. So that would be, you need to know how to do these. Significant figures. So be able to recognize the number of significant figures, right? I could give you a number like this and just the question could ask how many sig figs or how many significant figures are in this number. Or you might be doing a calculation and you need to know, right, how to correctly apply those sig figs in calculations. So in this calculation, right, you have 2 sig figs here. In this number, quarts to pints is exact because it's within the same system. Liters to quarts is not exact, so we have 4 sig figs here. Okay, and then milliliters to liters is exact, so we're limited by 2 sig figs, so we'd have 2 sig figs in the answer. Okay. All right, and then also know addition and subtraction rules as well. So I know how to calculate density, right? Density equals mass over volume. And you've probably seen a few problems there where you're given the volume or something and the mass and you need to calculate density, or you're given enough information to come up with the mass and you're given the density, or sorry, the volume and required to do density and stuff like that. But you just need to know that equation. And then using density as a conversion factor. So we usually see this if we're converting volume to, so when you go from volume to mass, right? Or from mass to volume, because the density is a relationship between mass and volume. It allows you to convert between volume and mass or mass and volume, right? Okay. All right. Temperature. Pay attention, some problems might have temperatures in Fahrenheit and you want to convert them to Celsius when you're working with equations and stuff like that. Or you might come up with an answer in Celsius, but all the answer choices have Fahrenheit. So you'll need to be able to do that conversion, but that equation is on the equation sheet to be able to do that. Heat calculations, right? You got Q equals MCAT. So we've talked about this when adding energy to something or with calorimetry, stuff like that. You could need to predict a final temperature after you add heat to something, right? So you'd solve for delta T, right? So start with solving for delta T in this case. And then you just need to add the delta T to whatever the initial temperature is, right? So if the problem says you start at 25 degrees and your delta T was 5 degrees, positive 5 degrees, then you would be at 30 degrees as your final temperature. So just being able to do those kind of calculations. When do the calculations when temperature is constant, right? When phases are changing, so from like a liquid to a gas or a solid to a liquid, you have a different equation, right? So that's heat equals mass times the heat of vaporization or fusion or sublimation, okay? So remember the heat and cooling curves. So here's an example of a problem that we can go over. So 25-gram ice cube is at 0 degrees and heated until it melts. Water continues to be heated until all boils away. How much heat was required for this process? So I think I've told you that what I like to do is draw the heating curve for these problems and then identify where I'm starting and where I'm stopping. Okay, so here we have a 25-gram ice cube at 0 degrees. So we're starting here. The ice cube melts. It then goes up to 100 degrees. And then heat is continued to be added until it all boils away, until it's all in the gas form. So all the horizontal lines, if you remember, you have Q equals M delta H, okay? So that's Q1. You can have Q3 here equals M delta, H. And then the diagonal lines are going to be Q equals M cat. Okay. There we go. And then just remember, going from solid to liquid is fusion, and liquid to gas is vaporization. I think it's easier just to remember the vaporization part, right? Like it's becoming a vapor. And then the other one's just fusion. So that's kind of how I remember them. Heat of sublimation is rarely used or seen, right? It's going from a gas to a solid directly, or from a solid to a gas directly. And it's not even pictured on the heating curve here, but that's what you would use if you were doing that kind of problem. Okay, you'd solve for all the different heats using the information you have, and then you add them all together to get the total heat transfer during that process. And 18 kcals would be the answer if you're observing the sig figs. Also gotten some questions on like when to round to the correct number of significant figures. And the answer is it doesn't really matter. It's easier to just round as you're going along. So here this was rounded, right, to 2.0, 2.5, and 14, and then it was added up at the end. So I think you can, it's kind of interesting if you actually just do the problem rounding while you do it or at the end. You'll see that you will get like a slightly different number probably, but once you round it to the correct number of sig figs, it really doesn't matter. You might, for example, you might get 19 here or something if you did it differently, or 17. But if you remember, this last digit is estimated anyway. So in terms of significant figures go, it's really kind of the same thing. And on the exam, the answer choice would be you wouldn't have an answer choice that is like, you'd get this answer if you rounded before, and another answer choice where you'd get it if you rounded at the end instead. You'll find the closest answer to whatever your calculation is. Okay. Okay, getting into chapter 3, we start talking about calorimetry. So just remember the big C calorie is different than the little c calorie, right? So the big C calorie is also written as like a kcal, okay? Sometimes you just hear it called like a food calorie, okay? Okay, and then energy density. I think there were a couple problems like this. It wasn't as prevalent, I guess. But it would be the amount of heat per mass of something. So like a carrot might have an energy density, like how many calories per gram of carrot or something like that, right? That's an energy density. Caloric values, kind of what you probably are more familiar with, like on the back of a nutrition label or something, like how many calories per candy bar given a certain amount of weight. Anyway, often it's not always that this is used to solve a problem, but a lot of times when you solve a problem, the units are in kcals per gram, right? So like the question might say how many calories are in butter or something like that, right? And you're going to do some calorimetry work to figure out how many calories are in a certain sample of butter or something, and then divide by the grams that you had in that sample. We saw one of those in the lectures that we went through. I think it was with butter. And so you're going to figure out the amount of energy per gram of butter or something like that. It's kind of what you would be looking for there. Okay. All right. Chapter 4 is to be able to convert elements to symbols and element names to symbols and symbols to element names. Again, I'm only requiring this for elements 1 through 20. Those are the ones that you're going to use most often. You will use the other ones sometime and you'll see them on the exam, but you'll have that chart with elements 21 through 118 that has the name and the symbol. So if palladium or chromium shows up on the exam, you'll have that to help you out there. Okay. Understand the periodic table. So understand groups and what's a group, what's a period, right? Where are the metals, where are the non-metals, where are the semi-metals. Sometimes these are called like metalloids. Okay. Atomic number is the number of protons. Atomic mass would be the protons plus neutrons, right? And then names of these common groups. So there's really 4 to know. You have the alkaline metals, alkaline earth metals. Those are the first 2 columns. Then the last 2 columns are halogens and noble gases. Right? Okay. Okay, so atomic theory. So be able to look at an element given an atomic number and a mass and be able to identify how many protons and neutrons in the nucleus. Also, with a given number of protons, you should be able to know the number of electrons if it's a neutral atom. So know atomic number, mass number, and the different isotope symbols. So isotope symbols are like, okay, so for carbon, you might have something like this, or you might see it written as carbon-12, okay? So that would tell you 6 protons. If you're looking at this symbol, you have 6 protons, the mass is 12, so you'd have 6 neutrons. If you were given this, you can look up on the periodic table and find that carbon is number 6, which means it has 6 protons, and then this gives you the mass, which helps you determine the number of neutrons, right? So you see either one of these in a question. Okay, atomic orbitals, awesome. So we talked about electron configurations here. So you need to know the order in which the sublevels fill, right? So if you're writing out an electron configuration for something, you need to know if it's like how it goes 1s, 2s, 2p, 3s, 3p, right? And that you just use the periodic table for. You got 1s, 2s, 2p, 3s, 3p, 4s. Then you have 3d, then 4p, then 5s, then 4d, right? The order gets complicated, but just following along like left to right, like you're reading a book, really, kind of like you're reading the periodic table. It shows you what order to fill the sublevels as you write an electron configuration. And then again, there are multiple exceptions, and your homework may have had some that I don't really care if you know off the top of your head. Just know chromium and copper. Those are here and here. And those are where you'll see two exceptions. There are other exceptions as you go down the periodic table, but these are the only two that I really care that you know as far as the exceptions go. And then obviously any other element, so like carbon or something, right? You should be able to write the electron configuration for carbon or for any element that I choose, really, okay? But I wouldn't choose anything that's has an exception unless it was chromium or copper. Okay. All right, no trends. So size we talked about. The atoms get smaller as you move to the right and up. And if you want to look up the reasons for that, that was in the lecture that we talked about. Ionization generally as you move right across the periodic table goes up. And then just know the two exceptions, right? The two exception spots, right? It's basically between this column and this column that you would see it. So between beryllium and boron, or between magnesium and aluminum. And then also between nitrogen and oxygen, you'd see it again, okay? So know those. Again, on a test, if I'm comparing ionization energies, I wouldn't ask you, or size, right? I wouldn't say like, which is bigger, boron or chlorine, right? I mean, it's kind of hard to tell, even if you can see it on here. But it's hard to compare elements that are in a different row or a different column. So I might list boron, aluminum, gallium, and indium and say which one's biggest, right? And then you know as you move down, they get bigger. Or I could do like aluminum, silicon, phosphorus, sulfur, and compare those four and ask you to know that. But yeah, like I wouldn't say like the difference, like which is bigger, chromium or tin, right? That would be difficult to do just using the general trends that we've learned. And same thing with ionization energy. It would be moving across, I'd ask you to compare ionizations moving across the row or across a column, because we know as we move to the right, the energy increases, besides the exceptions, obviously. And then as we move down a column, that the energy decreases, okay? All right. Okay, and then moving into radioactivity, so you should know the name, charge, and mass for the 4 types of radiation that we talked about, right? Alpha, beta, positron, and gamma. And then be able to solve the nuclear reactions. So you probably remember these from the lecture and the homeworks. So you're just balancing the masses on both sides. So like you have 277 plus 1 is 278. And here's 208, so we're missing a mass of 70 here, right? And then we have 112 and 0 for the atomic numbers on the right side. And then we have 82, which means we're missing a mass of 30. All right, so then you should be able to identify, using the atomic number, identify which symbol using the periodic table, and then you can put the mass in there as well. Cool. So then moving on down, know the difference between the different units in radiation, just kind of what they're used for, and yeah, basically that. Half-life, so how much is left after a certain number of half-lives, or if I tell you that there's 25% of the original sample remaining, you should be able to identify that 25% means that it went through 2 half-lives, right? It went cut down to 50%, then down to 25%. And again, I'm not going to ask you how many half-lives if 30% is remaining. We haven't talked about how to do that, and we're not going to. So just know the general, like 50% or 25% or 12.5%, right, as you go. We will only use like whole numbers, right, of atomic or of half-lives, basically. Okay. Moving into chapter 6, how many valence electrons are in each group? So could ask, how many valence electrons does chlorine have? Or how many valence electrons does beryllium have? Okay, and so be able to just look at the group number, and you can determine it easily that way, right? So like 6 valence electrons for oxygen, sulfur, or selenium. Or you could also write out the electron configuration for these and figure it out from that. This is just kind of the shorthand method. And then you should be able to predict ionic charge. So predict what charges does oxygen, or what ion does oxygen form, right? And remember, we're trying to get to a noble gas configuration. So oxygen would have to gain 2 electrons, so it would have a 2- charge. Sodium would need to get rid of an electron, so it would have a +1 charge, right? We've talked about this. Be able to predict the ionic charges for these. And then also the number of covalent bonds that can form. So when you draw out the valence electrons for oxygen, for example, you have 2 free valence electrons, so it could form 2 different bonds, right? Fluorine has 1, it would form 1 bond. Nitrogen has 3, so it would form 3 bonds, right? In general, we have seen exceptions with Lewis acids where oxygen only forms 1 bond or something like that, but just know in general that it can form, oxygen would form 2 bonds unless there was a charge or something like we've seen before. Okay, polyatomic ions, the name of them, the formula, and the charge on them, and I'll talk about which ones to know in the next slide. So for ionic compounds, right, you basically need to be able to go from the name of an ionic compound to the formula, and from the formula to the name. That's really essentially what you need to be able to do. But just remember, the total positive charges and total negative charges need to be equal in an ionic compound. And you name the cation first, then the anion with the IDE ending. Okay, I should probably add that. Anion name with the IDE ending. And then when you have a transition metal, you need to specify the charge, right? So for iron, where there's multiple charges that it could take on, if it's in a, so for like, if it was in iron chloride or something like this, then it would have a 2+ charge. If the compound was iron chloride with 3 chlorides, then it would have a 3+ charge, and you need to signify that with Roman numerals. Okay. So these are the polyatomic ions that you need to know, kind of summarized. And I know, looks like a lot, but just remember the rules. So ammonium acetate, hydroxide, and cyanide, right? Those ones you're just gonna, there's like one form of them, right? So you have NH4, acetate, you got, what's that, C2, H4, oh, actually H3, O2, right? So I gotta draw it out real quick. This is an OChem drawing. Okay, just double checking. All right, yep, C2, H3, O2, the minus charge on it. Hydroxide is OH, and cyanide is a CN, okay, with a minus charge. So then for all the rest of these, you know, really you're just memorizing the 8 form of all these. So there's all these ones. So it's 1, 2, 3, 4, 5, 6, 7, 11 polyatomic ions basically you need to know. And then just know the rules to go from like the 8 form to the per form. So like if we look at bromate as an example. Okay, so bromate would be Br3 with a minus, right? This is bromate. If you add an oxygen, right, the charge stays the same and it becomes per bromate. If you take away an oxygen, the charge stays the same and becomes bromite. And then if you take away two oxygens, two oxygens, charge stays the same, and you have hypobromite. Okay, so know that you really just need an 8 form and then those rules, and that gives you access to all these. And then just know if you add a hydrogen that the charge goes down by 1, and charge goes down by 1, and you put the name hydrogen in front of it. It could be hydrogen, or sometimes you see the prefix bi, so it could be hydrogen carbonate or bicarbonate. So hydrogen carbonate or bicarbonate, either one would work. So hopefully that's a pretty good list of like what is free game, but it looks a little more intimidating than it really should, I think. Okay. Last thing you'll need to know is covalent compounds. So the octet rule, right? Identifying valence electrons, and then being able to draw the Lewis structures. So with oxygen, if you draw out the valence dots around it, you can form one bond between this hydrogen and one between that hydrogen, right? That's the Lego method. And then there's also the book method, if that's working better for you, that you can use. And then be able to name, right? So go from formula to name, or from name to formula for any of these. And then with covalent compounds, you just remember that you're using the mono, di, tri, stuff like that. But if it's mono, if it's mono, then you generally leave it out. So like nitrogen dioxide or dinitrogen oxide. This could be mononitrogen dioxide or dinitrogen monoxide, right? So you can choose how to do it there, but just know that you could put mono in front of it. You might see that on the exam as well. But as far as you reporting a name for something, you can choose whether to put it on there or not. Okay. All right, I think that's it. So that was, we're good. That was a quick overview there of all the things you need to know, and hopefully that can clear up what's expected on the first exam, what you need to memorize, what you'll be given, and what you have access to for the first exam. So I would recommend trying to get ahead a little bit. The exam goes from lectures 1 to 11, and lectures 10 and 11 are on the schedule to be watched on Monday, July 6th, but the exam, obviously it closes July 7th, the next day, so you'd only have like 1 day to learn that stuff. And so I would really try and get ahead and try and get through lecture 11 by the end of this week, so you at least have some time to study before the first exam. So that's it, and email me questions if you have them about the exam, and we'll see you next time.